Today's show is brought to you by Lootcrate.com. If you're as geeky and nerdy as me, you'll love it. It's like Comic-Con in a box. Save 10% on any new subscription by using the link. Try lootcrate.com/spacetime and enter the promo code BRIDGE10 for 10% savings. That's BRIDGE10 for 10% off. This is SpaceTime, Series 20, Episode 94. Coming up on SpaceTime. Infant stars discovered where they shouldn't be, near a supermassive black hole. Rosetta provides a recipe for making a comet. And the multi-million-dollar Russian rocket failure after someone punched in the wrong coordinates. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered 11 newly formed infant protostars where they shouldn't exist, right next to the monstrous supermassive black hole at the centre of our galaxy. The findings, reported in the astrophysical journal Letters, have shocked scientists as regions around black holes are racked with powerful gravitational tidal forces and bathed in intense ultraviolet and X-ray radiation, generating extremely harsh conditions that shouldn't favour star formation. Amazingly, the protostars were all discovered within 3 light-years of the supermassive black hole. Protostars are the embryonic formative stage between a dense molecular cloud of gas and dust and the young main sequence star. Astronomers believe that most, if not all, galaxies play host to a central supermassive black hole. The one at the centre of our galaxy, the Milky Way, is known as Sagittarius A star. It's located about 26,000 light-years away and contains over 4.3 million times the mass of the Sun. The new stellar discoveries were made by the European Southern Observatory's Atacama Large Millimetre Submillimetre Array Telescope, ALMA. ALMA revealed the telltale signs of the 11 low-mass stars, all forming incredibly close within 3 light-years of the monstrous black hole. Now, at this distance, the gravitational tidal forces driven by Sagittarius A star should be energetic enough to rip clouds of gas and dust apart long before they can collapse down to form new stars. The presence of these newly discovered protostars suggests that the conditions necessary to birth low-mass stars may exist in even the most turbulent of regions within our galaxy, and for that matter, probably in similar locations throughout the universe. Astronomers describe the discovery as genuinely surprising, one that demonstrates just how robust star formation can be, even in the most unlikely of places. The ALMA data also suggest that these protostars are only about 6,000 years old. It's the earliest stage of star formation ever found in such a highly hostile environment. Astronomers identified the protostars after seeing the classic double lobes of material that bracketed each of the stars. These cosmic hourglass-like shapes are signatures of the early stages of star formation. Molecules, like the carbon monoxide in these lobes, glow brightly in the millimetre wavelength light that ALMA observes. Protostars form in interstellar molecular clouds of gas and dust. Dense, cold pockets of material in these clouds collapse under their own gravity and grow by accumulating more and more star-forming gas, until the temperatures and pressures at the centres of these clouds grow high enough to begin fusing hydrogen, and then, voila, a star is born. However, a portion of this infalling material never makes it into the star. Instead, it's ejected as a pair of high-velocity jets from the protostar's north and south poles. Extremely turbulent environments, such as those thought to exist around a black hole, can disrupt the normal procession of material into a protostar, while intense radiation from massive nearby stars and black holes can heat up and even blast away the parent cloud, thwarting the formation of all but the most massive of stars. Vast stores of interstellar dust obscure the heart of the Milky Way, where its supermassive black hole resides, hiding it from optical telescopes. However, radio waves, including the millimetre and submillimetre light seen by ALMA, are able to penetrate this shroud of dust, giving radio astronomers a clearer picture of the dynamics and contents of this hostile environment. Prior observations of the region surrounding Sagittarius A star had provided some tantalising hints of several infant stars, but the findings weren't conclusive. These objects, known as proplyds, are common features in more placid star-forming regions, but it was the new measurements by ALMA which provided the more conclusive evidence for young star formation activity. Though the galactic centre is often considered a challenging environment for star formation, it may well be possible for especially dense cores of hydrogen gas to venture into this region and forge new stars. Astronomers also used ALMA to confirm that the masses and the momentum transfer rates, that is, the ability of the protojets to plough through the surrounding interstellar material, are consistent with young protostars found throughout the disk of our galaxy. The study's authors say there are several pathways in which stars may be able to form in this inhospitable region of the galaxy. For this to occur, outside forces would have to compress the gas clouds near the centre of the galaxy sufficiently to overcome the violent nature of the region, thereby allowing gravity to take over and form stars. Astronomers speculate that high-velocity gas clouds travelling through the galaxy could aid star formation as they force their way through the interstellar medium. It's also possible that jets from the black hole itself could be ploughing through the surrounding gas clouds, compressing material and triggering this burst of star formation. Whatever the cause, the next step's to take a closer look to confirm that these newly formed stars are being orbited by disks of dusty gas. If so, it's likely that planets will eventually form from this material, as is the case for young stars further out in the galactic disk, such as the planets which formed around the Sun in our own solar system. This is Space Time. I'm Stuart Gary. Scientists have discovered the recipe for making a comet. The findings, reported in the monthly notices of the Royal Astronomical Society, provide the first quantitative analysis of the chemical elements that make up the cometary dust of the Comet 67P Churyumov-Gerasimenko. The study is based on a detailed analysis of data collected by the COSMA instrument aboard the European Space Agency's Rosetta spacecraft, which studied Comet 67P from August 2014 through to September 2016. Scientists found that almost half of the dust Comet 67P emits into space is composed of organic molecules, including the most pristine carbon-rich material known in the solar system. In fact, researchers believe this material has hardly changed since the very birth of the solar system 4.6 billion years ago. When a comet travelling along its highly elliptical orbit approaches the Sun, it begins to heat up, causing frozen gases to become volatile and evaporate. As they do so, they drag tiny grains of dust from the comet with them, forming the comet's distinctive coma surrounding its nucleus and its twin tails. Capturing and examining these grains provides the opportunity to trace the building materials of the comet itself. So far, only a few space missions such as Rosetta have succeeded in this endeavour. Earlier missions, such as the European Space Agency's Giotto spacecraft, conducted a flyby of Comet Halley. And NASA's Stardust sample return mission was able to collect cometary dust from the Comet 81P Wild-2. But both missions only provided scientists with an ever-so-brief snapshot in time. In fact, in the case of Stardust, which raced past its comet in 2004, the dust had changed significantly during capture, so that a quantitative analysis was only possible to a very limited extent. Unlike their predecessors, the Rosetta team were able to collect and analyse cometary dust particles of various sizes over a period of around 2 years, as Rosetta orbited the comet and even sent a probe down to its surface. The COSMA instrument collected more than 35,000 cometary dust grains, ranging in size from around a millimetre down to just 0.01 millimetres across. COSMA made it possible to microscopically study individual dust grains, and then bombard them with a high-energy beam of ions. The secondary ions emitted by this process could then be weighed and analysed using COSMA's mass spectrometer. For the current study, scientists focused on just 30 dust grains they thought had the properties they needed to ensure a meaningful analysis. Their selection included dust grains from all phases of Rosetta's mission and of all sizes. The study's lead author, Dr. Martin Hilchenbach from the Max Planck Institute, says all the grains had a very similar composition, with the comet's dust consisting of the same ingredients as the comet's nucleus. The authors found that organic molecules accounted for about 45% of the mass of the solid cometary material, making it among the most carbon-rich bodies in the solar system. The rest, about 55%, is composed of mineral substances, mainly silicates. Interestingly, the authors found almost exclusively non-hydrated minerals, meaning there wasn't much in the way of water compounds. Hilchenbach says that like all comets, 67P does contain water. But because comets spend so much of their time in the outer frozen rim of the solar system away from the warmth of the sun, this water has remained frozen rock solid, leaving it unable to react with cometary minerals. The researchers therefore regard the lack of hydrated minerals in the comet's dust as an indication that 67P contains very pristine material. They say their conclusion also supports the ratio of certain elements, such as carbon to silicon, which is very close to the Sun's ratio, and which is also thought to reflect the ratio found in the very early solar system. I'm Stuart Gary. You're listening to SpaceTime. Okay, let's take a break from the show while I tell you about one of the great deals we've got from one of our sponsors. Lootcrate are offering SpaceTime listeners the chance to save 10% on any new subscription. Make sure you use the link trylootcrate.com/spacetime, then enter the promo code BRIDGE10 for the 10% discount. Lootcrate is like Comic-Con in a box, a monthly mystery crate that delivers the best in geek plus gaming gear. If you're as geeky and nerdy as me, you'll love it. It includes collectibles, apparel, tech gadgets, art, and other epic gear. For less than $20 a month, you'll get between 6 and 8 items that include licensed gear, apparel, collectibles, unique one-of-a-kind items, and more. A subscription would make a great gift idea for any geeks in the family that you may be having trouble finding that ideal present for. It's the gift that just keeps on giving month after month. And by supporting Loot Crate, you also support SpaceTime. Again, to save 10% on any new subscription, go to trylootcrate.com/spacetime. That's trylootcrate.com/spacetime to save 10% on any new subscription. And remember to enter the promo code BRIDGE10 for 10% off. That's BRIDGE10 for 10% off. And now, it's back to the show. Mission managers at the University of New South Wales say their Buccaneer satellite has attained a stable orbit and is operating nominally. Buccaneer is a 3-unit CubeSat built by the University of New South Wales in Canberra in partnership with the Australian Department of Defence's Defence Science and Technology Group. The spacecraft will help calibrate Australia's unique Jindalee over-the-horizon radar network and provide crucial data on predicting the orbits of objects, including space junk. Buccaneer was deployed aboard the joint NASA-NOAA JPSS-1 weather satellite mission, which flew from Space Launch Complex 2W at the Vandenberg Air Force Base in California last month. The flight marked the penultimate launch of the Boeing Delta II rocket, which has been a workhorse for NASA and the American space launch industry since first entering service back in 1989. Buccaneer, together with 4 NASA CubeSats, piggybacked along with the primary payload for the ride into orbit. Buccaneer is now undergoing preliminary testing in orbit, with scientists and engineers communicating with the spacecraft and obtaining telemetry. Over the next few weeks, the spacecraft will undergo operations to check and commission its onboard systems before undertaking its risk management activities and experiments in early 2018. Buccaneer is the first of 8 spacecraft being constructed by the University of New South Wales, which are being developed to gather research data for projects ranging from remote sensing to ultra-secure quantum satellite communications networks. Over 40 space engineers, scientists and PhD students are involved in the project, which aims to establish a sustainable niche domestic space industry. University of New South Wales Canberra Space Director Professor Russell Boyce says small spacecraft like Buccaneer will play an important role in gathering data for research as well as demonstrating space-based capabilities.
So the Buccaneer spacecraft is going quite well so far. We're still in the early stages of the mission. We've been spending time firstly establishing communications with the spacecraft, making sure that basically the system is healthy, that it's not suddenly decided it's dead on arrival, anything like that. So that's been successfully done. And we're now at the point where we can prepare for certain key steps, such as firing up the attitude determination and control system to be able to detumble the spacecraft. At the moment, it's doing slow cartwheels in orbit.
Is that normal?
Yes, yeah. So what happens when you launch these things, the rocket gets into the right orbit and a command is sent to the flap, the door on the dispenser for the CubeSat, and that opens up and there's a string that shoves the CubeSat out into space. And the chances of it shoving out into a straight line and not having any rotation about it, effectively zero. You get some sort of tipping effect as it pops out. And so it goes into this slow cartwheeling motion. And we've not yet instructed the spacecraft to detumble itself, so that's one of the next steps. And the process of doing that is, there's onboard sensors that detect the horizon, so the edge of the Earth, and detect where the sun is, and it works out which way's up and which way's down and starts to activate, they're called reaction wheels on board the spacecraft.
These are like gyroscopes.
That sort of thing, yeah, which counter the rotational motion of the spacecraft and bring it to exactly how we want it. And we continually use that system throughout the whole mission. From time to time, change the way the spacecraft is pointing so that we get optimal solar panels are pointing at the sun, basically. Or we're optimally pointing the antennas down to the ground station. That sort of thing is what this attitude control system is for. So that's one of the next steps. We need to deploy solar panels. We need to go through a thorough check of all of the onboard subsystems as well as the payload, just checking that we're good to go to be able to start the real purpose of the mission, which we're not planning to start until the early part of next year. It is a sun-synchronous orbit, the same inclination as JPSS-1, but it's a much higher area to mass ratio than that weather satellite, which means it's experiencing the effects of drag in a much stronger way, which means it's actually counterintuitively way ahead of the weather satellite. It slows down, spirals in just a bit, and therefore its orbital period is much less, so it looks like it's going faster.
Mm-hmm. That also means it's suffering more orbital drag?
It is suffering orbital drag, so it will naturally spiral back into the Earth's atmosphere and burn up in about, let's say, 4, 5, 6 years, something like that. It's hard to determine, which comes back to the need to understand the way these objects interact with their environment up there.
Can you control the re-entry at all, or you've only got the gyrodynes, the gyroscopes, to control its orientation?
Yeah, well, with the reaction wheels and therefore control of the orientation, we can deliberately control how much drag that this thing is experiencing. So it's an aerodynamic effect. Mm-hmm. So if you full on into the breeze, much higher drag, you can rotate the spacecraft 90 degrees and you'll get a minimum drag configuration. So you can tweak and tune it to some extent.
You also, I guess, skip across that rarefied atmosphere to a degree as well.
It does provide some lift. Mm. It's an order of magnitude less than the drag. That lift, it's not only vertical lift, we call it span-wise lift orthogonal or forces orthogonal to the direction of travel. And so that means you can move around from side to side a little bit in the orbit as well.
What will Buccaneer be doing while it's up there?
The main mission is to detect the Dawn over-horizon radar network from space.
And what is Dawn? What is the Jindalee over-the-horizon radar system?
It's an early warning radar network that was developed by Defence Science and Technology Group and operated by Defence. It uses a combination of radar and ionospheric physics, which means radar signals are beamed up into space and they reach a level called the ionosphere, where most of the very rarefied particles up there are actually ions and electrons instead of atoms. And because they're electrically charged particles, the radar beam reflects off that layer. And that's how it ends up being able to come back down to the Earth over the horizon. And then it reflects off objects, goes back up to the ionosphere and is detected back down in Australia. So it can see thousands of kilometres rather than just line of sight. Defence is going through a process of upgrading that. They want to improve it. And to improve it, you have to understand how it's interacting with the ionosphere. And the only way you can do that is actually to get up into the ionosphere and make a measurement.
Adding complication to that is the fact that the ionosphere is constantly changing depending on geomagnetic storm activity.
It's changing in a very, very dynamic way, both spatially and in time, yeah.
And so that's the primary function of this mission, but there's a secondary function as well, isn't there? You're testing a new structure that's going to be deployed from the spacecraft.
Well, that is the antenna. It's not so much testing the structure, it's more just confirming that the structure will perform its duty in space appropriately. It'll be stable. It's a large, lightweight, flexible structure, and we need to confirm that it will remain in its deployed position in a stable way to be able to then fly the main mission and use it with a radar receiver.
Buccaneer also has other things it can do, including looking at space junk.
Where the space junk comes in, this is part of the effort in Australia to play an international role in what we call space situational awareness. Currently, Defence is operating a large radar system, the US Air Force, out at Exmouth in Western Australia, and there is a very, very large space surveillance telescope being relocated from the US to that same place to be able to monitor space junk and satellites in orbit as part of the International Space Surveillance Network. Australia wants to provide more than just real estate for ground-based sensors. It wants to add value to that by improving the state-of-the-art of orbital predictions of the way that satellites and space junk behave in orbit. And UNSW Canberra Space, one of the main themes of our research is improving the state-of-the-art of orbital prediction, which means understanding how the objects interact with their environment in low Earth orbit, particularly in the ionosphere. And therefore, we're going to use Buccaneer, both risk mitigation mission and main mission, as well as the missions that we're contracted to fly for the Air Force. We're going to use those. We'll be in control of the object and we'll instruct the satellite to undertake some prescribed motions. We'll rock it backwards and forwards in a predetermined way, and we'll be watching from the ground with our telescopes. The sun reflects off the object, and because we're rocking it backwards and forwards, we get a particular behaviour of light coming off it, just as that happens with space junk that we're not in control of, and we can start to understand what the object might be doing that we're observing from the ground that we're not in control of.
So we'll be using Buccaneer as a test object in space to calibrate and perfect the ground-based observations.
Exactly. Yep.
Buccaneer is not the only CubeSat you guys are currently working on. You've got, 5 in the pipeline, 3 more potential?
So the 2 Buccaneer satellites are 2 of the 5. The other 3 that are funded are 3 spacecraft for the Royal Australian Air Force. So we have a $10 million contract from Air Force. Some of it is for ground-based space situational awareness research, but most of the funding is leading to 3 spacecraft being flown, one which is almost completed and will fly in the first half of next year, to be followed about a year later by a pair of larger CubeSats, 6U CubeSats, that will fly in formation. And the purpose of all of those 3 CubeSats is a maritime surveillance demonstration, exploring the art of the possible and growing capability within Australia to develop and operate space missions.
That's Canberra Space Director Professor Russell Boyce from the University of New South Wales. And this is SpaceTime. I'm Stuart Gary. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Russia's second space launch from its shiny new Vostochny Cosmodrome in the country's far east has ended in a multi-million-dollar disaster, losing the mission's 19 satellites. Early indications point to the wrong settings being programmed into the Soyuz frigate upper stage, causing the mission to crash and burn. The Russian Federal Space Agency Roscosmos has confirmed that the Soyuz 21B's initial ascent into orbit went smoothly, with first, second and third stages all firing and separating on schedule, placing the frigate upper stage and its payload into a ballistic arch flying over the Arctic and North Atlantic Oceans. The Frigate M upper stage was then expected to undertake an initial 90-second engine burn to insert the stack into a transfer orbit. That was to be followed by a series of 6 additional burns over several hours, designed to place the 19 satellites into 4 separate orbits. However, mission managers were unable to establish contact with the Frigate M upper stage or any of the satellites in the payload. Believe it or not, it's now understood that the frigate was programmed with the wrong flight control system settings. The data it was given was for a mission flying out of the usual Buccaneer or Placest cosmodromes, and not out of the new Vostochny Cosmodrome. That failure would have hit as soon as the frigate and its payload separated from the Soyuz launch vehicle's third stage. See, that's because the frigate and Soyuz each use different flight control systems. Frigate's flight control system would have changed the stack's orientation in space, trying to compensate for what it perceived as a major deviation from the correct attitude. And this would have caused the first main engine burn to fire in the wrong direction. That in turn would have caused the frigate and its 19-satellite payload to begin flying on the wrong course, most likely re-entering the atmosphere and burning up, with the debris then falling into the North Atlantic Ocean. The mission's primary payload was the 2,750-kilogram Meteor M21 remote sensing weather satellite, which was to be placed into an 825.5-kilometre high polar orbit. The cluster of 18 secondary satellite payloads aboard the mission included 10 4.5 kilogram Lima 2 navigation satellites, 2 11 kilogram Corvus BC-3 land mapper remote sensing satellites, an 86 kilogram Russian Baumans 2 remote sensing satellite, a 3 kilogram German D-Star 1 communication satellite, a 70 kilogram Leo Vantage communication satellite, a 6.5 kilogram Norwegian Space Center navigation satellite, a 22 kilogram Astroscale Japanese astronomy satellite, and a 4.7 kilogram Swedish Earth physics satellite. This isn't the first multi-million-dollar screw-up of this type. You may recall back in 1999, NASA's Mars Climate Orbiter spacecraft crashed and burned on the surface of the Red Planet after contractors used imperial rather than the metric measurements specified by NASA for the spacecraft's flight system controls. I'm Stuart Gary. You're listening to SpaceTime. In last week's science report, we covered the latest test flight of North Korea's new toy, the Wysong 15 Intercontinental Ballistic Missile. In the hours following that report, Pyongyang released the first images of the new missile, showing it's far more than just an improvement in design over the Wysong 14 flown back in July. The Wysong 14 itself was based on the earlier Wysong 12, first tested in May. The newly released images show the Wysong 15 is an entirely new and significantly larger missile, using a two-chambered main gimbaled engine system for steering. That's a significant advance over the Wysong 14 single RD-250 or modified RD-251 rocket motors, which used 4 vernier steering thrusters based on older Scud missile technology. The Wysong 15 rocket motor's two-chambered configuration is still similar in appearance to the original RD-251 engine design built for the former Soviet Union in the Ukraine. This suggests around 80 tons of thrust force at liftoff, giving the Wysong 15 a launch mass of around 40 to 50 tons. Experts describe the new first-stage booster as being similar in design to the Titan II missile. The 53-minute test flight of the Wysong 15 ICBM centered on a high-lofted trajectory reaching an altitude of 4,475 kilometers before splashing down 950 kilometers downrange from its launch pad. The new missile gives North Korea an effective range of over 13,000 kilometers. That's enough to reach most of the continental United States east coast, as well as Europe or Australia. The new upper stage is also larger than the Wysong 14, indicating more fuel for a longer range or larger payload. Experts suggest the upper stage is based on Iranian missile technology used for Tehran's rocket program, which, like North Korea, was always designed to provide a delivery system for Iran's own secretive nuclear weapons program. North Korea and Iran have a decades-long and deeply intertwined joint technology development program, sharing nuclear, weapons and missile technology. It's also likely that the Wysong 15's upper stage still uses the 4 small rocket motors derived from the Soviet-era R-27 missile, NATO codename Alamo. Both Iran and North Korea already operate the R-27. The latest estimates indicate the Wysong 15 could deliver a 1,000 kilogram payload to just about anywhere in the United States. North Korea says the test missile was equipped with a super-large heavy warhead, and that's believed to indicate a correct weighted dummy version of its thermonuclear warhead. Analysts say the new missile's nose cone appears to be designed for multiple re-entry vehicles, which would indicate several decoys as well as a moderately sized nuclear warhead. Meanwhile, the Japanese military has confirmed earlier reports that the missile's re-entry vehicle failed to successfully re-enter Earth's atmosphere, breaking into at least 3 pieces before crashing into the sea between 250 and 370 kilometers west of the Japanese coastline. The newly released images also show a new larger 9-axle TEL, or Transporter Erector Launcher Truck, compared to the Chinese-built 8-axle transporters used for the Wysong 14, which Beijing claims it sold to Pyongyang purely for use as log transporters in the lumber industry. The new launch vision also shows that just like the Wysong 14, the new Wysong 15 was fired from a fixed launch pad rather than from the transporter itself. The launch was North Korea's 20th launch of a ballistic missile this year, and possibly its 3rd successful test flight of an ICBM following the 2 earlier launches in July. You're listening to Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found a link between the amount of time between pregnancies and the development of autism spectrum disorder in children. Researchers found that autism spectrum disorder was increased in second and later born children who were conceived less than 18 months or 60 or more months after a mother's previous birth. Other developmental disabilities were not associated with birth spacing. The findings, reported in the Journal of Autism Research, supports existing guidelines on pregnancy spacing and further highlights the association between autism and pregnancy health. Scientists at MIT have created a new way of turning carbon dioxide emissions from power plants into potential fuels and other useful chemicals for industry. The findings, reported in the journal ChemSus Chem, are based on a new membrane compound using lanthanum, calcium and iron oxide to filter carbon monoxide out of carbon dioxide exhaust gases while allowing oxygen to pass through. Scientists say the filtering process is driven by exhaust gas temperatures up to 990 degrees Celsius. The harvested carbon monoxide can then either be used as fuel or combined with other chemicals to produce hydrocarbons, methanol, syngas, or other substances. Well, you've probably heard this one before, but a team of scientists claim they've developed a new chemical that can prevent hair loss and promote hair growth. Yes, that's right, we're talking about a cure for baldness. Researchers claim their medication, called PTD-DMB, has already been shown to work on mice, and is now undergoing pre-human trial toxicity testing. Male pattern baldness accounts for over 95% of hair loss, with an estimated 2/3 of males experiencing some level of baldness by age 35 and a quarter by the time they're 21. Some 99% of products marketed in the hair loss treatment industry are totally ineffective despite the promises. The scientists in this latest study found that sufferers of hair loss had a significant amount of the CXXC5 protein in their scalp, and when that protein combines with damaged protein, it prevents the regeneration of hair follicles. The researchers say PTD-DMB retards that binding. They claim it will form the basis of a new drug that not only treats hair loss, but also regenerates damaged skin tissues. No word yet on when human trials begin. SpaceX and Tesla boss Elon Musk has won his bet to build the world's biggest battery in 100 days or it's free. The South African-born business entrepreneur built the new facility at Jamestown in South Australia with 40 days to spare. The $50 million 100-megawatt lithium-ion battery will store energy from the nearby Hornsdale wind farm. It'll also act as an emergency backup supply to stabilise the electricity network in South Australia whenever there's a shortfall, as there often appears to be in that state. The battery can store up to 129 megawatt-hours of electricity, meaning at full power it should last for a little over an hour, powering up to 30,000 homes. And finally for now, some bad news for Bigfoot fans. A new study of DNA samples claiming to have come from a yeti from the Himalayan mountains of Nepal and Tibet have instead turned out to have come from a dog, from Asian black bears, from Himalayan brown bears, and from Tibetan brown bears. The findings, reported in the Proceedings of the Royal Society B, supports previous evidence that the biological underpinnings of those mysterious legendary bipedal ape-like creatures said to inhabit the high mountains of Asia are actually nothing more than local bears. The mythology of a population of 8 to 9 foot tall human-like creatures is a common myth in many parts of the world. It's been sparked in part by fossil evidence of an ancient gigantic ape, Gigantopithecus blacki, which lived in Asia up to about 100,000 years ago. Gigantopithecus stood about 3 metres or 9.8 feet tall and weighed up to 600 kilograms. That makes it 3 to 4 times as heavy as modern gorillas and 7 to 8 times as heavy as Gigantopithecus's closest living relative, the orangutan. Sightings and footprints of yetis have been reported for centuries, with stories passed down from generation to generation. Similar stories in the United States and Canada have given rise to the legend of the Sasquatch or Bigfoot. That's been encouraged somewhat by hoaxes, such as the famous 1967 Patterson-Gimlin film claiming to be of a female Sasquatch. Later, an acquaintance of Patterson, Bob Heronims, claimed to have been the figure depicted in the Patterson film wearing a gorilla suit. No! You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Today's episode of SpaceTime has been brought to you by Lootcrate.com. It's the ideal gift if you're as nerdy as me or you know someone who is. It's like Comic-Con in a box, and you can save 10% on any new subscription by using my link. Try lootcrate.com/spacetime. Then just enter the promo code BRIDGE10 for 10% off. That's BRIDGE10 for 10% off.